Hello everyone, welcome. This is Miss Mace. In this video we will go through topic 2, atoms, elements and compounds. Part 2, isotopes for Cambridge IGCSE Chemistry syllabus 0620. First you need to define isotopes as atoms of the same element that have the same number of protons but different numbers of neutrons. Now, for any element or most elements in nature, they are found as a mixture of isotopes. We have the same type of atoms, all with the same number of protons, but they have a slight difference in their masses. For example, if you are looking for a sample of boron, boron in nature it exists as a mixture of two isotopes. They are called boron 10 and boron 11. Now 10 and 11 refers to the nuclear number or the mass number. You can notice both boron atoms have the same atomic number. That means both they have the same number of protons, which equals to 5, and the same number of electrons, which also equals to 5. But the nuclear number is different, so the mass number also is different. So if you are looking for the number of neutrons for the first isotope, you will say 10 minus 5, that equals 5 neutrons. For the second isotope, you will say 11 minus 5, that equals 6 neutrons. So there is a slight difference in masses between these two atoms. That difference will lead to a difference in the physical properties that are related to masses. But what about the chemical properties and how these atoms will react? Absolutely. They will react in the same way and they will have the same chemical properties. But why isotopes of the same element have the same chemical properties? Now, what controls the chemical properties of an atom is the number of electrons. So, we told you before that number of protons is the same and therefore the number of electrons also would be the same for isotopes. So, because isotopes have the same number of electrons and therefore the same electronic configuration, absolutely they will have the same chemical properties and they will react in a similar way. The other objective, you should know how to calculate the relative atomic mass, which is AR, of an element from the relative masses and abundances of its isotopes. Now, isotopes have different masses. So, when working out the relative atomic mass for an element, you must take its isotopes into account. An average value is calculated. Okay, how can we find the average value? So, should we just take the mass numbers for all isotopes and divide it over the number of isotopes? No, that is not the correct way how to do it. You should know that the abundance or the percentage of availability of each isotope, it's not the same. Some isotopes are more abundant than the others. So, how can we overcome that point? How can we consider that issue? You have to calculate the relative atomic mass. You have to do the following. You have to take the mass of the first isotope and multiply it by the abundance of the first isotope. Find the value and then add it to the mass of the second isotope multiplied by the abundance of the second isotope. Add it also to the mass of the third isotope multiplied by the abundance of the third isotope. Take the summation of all these values. Then divide it over the summation of all isotopes' abundances. To understand it better, let's take an example. Let's go back to boron. Boron has two isotopes, boron 10 and boron 11. Now, for a sample of boron, you will find that 20% of the atoms is boron 10 and 80% of the atoms are boron 11. So what should I do to calculate the relative atomic mass of boron? You have to take the mass of the first isotope, which is 10, and multiply it by its abundance, which is 20. Then add it to 11, which is the mass of the second isotope, multiplied by 80, which is the abundance of that isotope. Find the value and divide it over the total abundances, which is 20 plus 80. So do the calculations. 10 times 20 for the first isotope and add it to 11 times 80, which is the calculations for the second isotopes, add the values to each other, and divide it over the total abundances, 20 plus 80. Do your calculations, you will find the relative atomic mass for boron equals 10.8. So that's how we can do it. And by the way, this value, it is a common sense. Why? Because you can notice that the percentage abundance for boron 11 is greater than that for boron 10. So absolutely, the relative atomic mass should be nearer to 11 than that for 10. Let's take practice questions. Element T has two isotopes, T12 and T14. Which statement about these isotopes is correct? A. They have different chemical properties. Oh, no, they have the same chemical properties because they have the same electron numbers. Now, they have the same chemical properties, yes, because they have the same number of outer shell electrons. Yes, this is correct. Now, let's check C and D. They have the same nucleon number? No, absolutely. They have different nucleon number. They have different positions in the periodic table because they have different numbers of neutrons. No, the positions in the periodic table are the same because they have the same number of protons. Because what decides the position in the periodic table is the proton number, not the neutrons numbers. Now, another question. Two isotopes of sulfur are shown, sulfur 32 and sulfur 33. Use your knowledge of protons, neutrons, and electrons to answer the following questions. Describe how these isotopes of sulfur are the same and how they are different. Now, they are the same with number of protons and number of neutrons. Both isotopes have the same number of protons and both isotopes have the same number of electrons, but they have different number of neutrons. Explain why each of these isotopes have an overall charge of 0. Now, these isotopes are atoms. In atoms, number of positive protons equals the number of negative electrons. So the overall charge would be 0 because the positives will cancel the negatives. So because number of positive protons equals the number of negative electrons, the overall charge would be 0. Explain why both isotopes have the same chemical properties, because they have the same number of electrons and therefore the same electronic configuration. Another question. Atoms of the same element are known as isotopes. Sulfur 32 and sulfur 34 are isotopes of sulfur. Complete table 2.1 to show the number of electrons, neutrons, and protons in one atom or ion of these isotopes. Now, first we have atom of isotope sulfur 34 and then we have ion of sulfur 32. Start by looking for the number of protons. It is the easiest one to find because number of protons will not change and it equals to the atomic number, which is 16 for both. Now, find number of neutrons. How we find number of neutrons? Take the mass number for the first one, which is 34. So you will say 34 and minus 16. That equals to 18. So for the first isotope, we have 18 neutrons. Now, for the second isotope, we have mass number of 32. Say 32 minus 16, that would equal to 16 neutrons. Now for electrons. First of all, the first isotope is an atom. For atom, a neutral atom, number of electrons equals the number of protons. So absolutely there will be 16 electrons. But for the number of electrons in the second isotope, which is ion, how can I tell it is ion? Because there is a 2 negative charge. This 2 negative charge means that the sulfur gained 2 electrons. Gained 2 electrons, so the original number of electrons, which is 16, you have to add 2 electrons to it because this atom gained 2 electrons and therefore it changed to become 2 negatively charged. So totally there will be 18 electrons in this ion. Next question. Table 2.2 shows the relative masses and the percentage abundances of the two isotopes in a sample of sulfur. Relative mass of isotope, we have isotope 32 and 34. The abundance for the first one is 95, for the second it is 5. Calculate the relative atomic mass of this sample of sulfur to one decimal place. What should I do? I have to take the mass of the first isotope and multiply it by the abundance. So you will say 32 times 95 plus 34, which is the mass of the second isotope, times 5, which is the abundance of the second isotope. Then divide the summation of these values over the summation of all abundances, the 95 plus 5. So you have to say 32 times 95, which is the calculations for the first isotope, added to the calculations of the second isotope, which is 34 times 5. Find the value and divide it over 100, which equals to 95 plus 5. Do your calculations and you will find that the relative atomic mass equals 32.1. Remember to put your answer to one decimal place. Another question. The relative abundance for thallium, we have two isotopes, thallium 203 and thallium 205, is in the ratio 3 to 7. So here we do not have percentages. Calculate the relative atomic mass of thallium in the sample to one decimal place. What should I do? I don't have percentages. You have to do it in the same way. What should I do? Now, I will say 203, I multiply it with the 3, which is the abundance for the first isotope, then add it to 205 multiplied by 7 and divided over the summation of the abundances. Here I will say 3 plus 7 is the total of the abundances. So do your calculation as the following. 203 times 3 plus 205 times 7. Add the values and divide it over 10, which is the 3 plus 7, which is the summation of isotopes abundances. Do your calculations, you will find that the relative atomic mass to one decimal place equals 204.4. Another question. The relative atomic mass, AR, of an element is the average mass of its isotopes compared to one atom of isotope X. Now, this question is from topic 3. We will talk about it later, but let's answer it here. This isotope is carbon-12 isotope. A sample of magnesium consists of two isotopes with mass number 24 and 26. The relative atomic mass of magnesium is 24.3. Calculate the percentage abundance of the isotope of magnesium with mass number of 24. What should I do here? First of all, you have to apply the rule we just used before. You need to do a simple trick. You have to assume that the abundance for magnesium 24 is X and the abundance for magnesium 26 is Y. But we know that X plus Y, which is the total percentage abundances, equals 100. So you can rearrange this equation to say that Y equals 100 minus X. Keep this equation, we will use it later on. Now back to the rule we used it before and say the relative atomic mass equals the mass of each isotope times the abundance for all isotopes divided over the total abundances. Now here we have two isotopes. So the relative atomic mass equals 24.3. That equals to 24 times X. Here X is the abundance percentage for the magnesium 24 isotope, plus 26Y. Y is the percentage abundance for magnesium 26, divided over 100. The 100 is the total summation of all abundances for the two isotopes. Now, you can substitute instead of Y, you can say that Y equals 100 minus X. Do the substitution. Use your math and do your calculations. You will find that X equals 85%. Next question. The only naturally occurring isotopes in a sample of europium are europium-151 and europium-153. Europium has a relative atomic mass of 152, exactly in the middle, between the 151 and the 153. What is the percentage of europium-151 present in this sample? To three significant figures. Okay. Because the relative atomic mass is exactly in the middle between the 151 and the 153, so we are talking about equal ratios of both isotopes. So absolutely there would be 50% of europium 151 and 50% of europium 153. Now, to confirm this, you can do your calculations. You can assume that the abundance or the percentage for europium 151 equals X, and the percentage abundance for europium 153 equals Y. Now, X plus Y absolutely will equals 100. You can rearrange the rule to say that Y equals 100 minus X. Keep this equation, we will use it later. Now, to find the relative atomic mass, which is 152, we have to multiply the mass of each isotope times its abundance. So for the first one, it is 151 times X plus 153, which is the mass of the second isotope, times Y, which is its abundance, as we just assumed. Do the calculations and divide it over the total abundances, which is 100. Now, substitute instead of Y, use this equation. So you would say 152 equals 151x plus 153 times 100 minus x. All that is divided over 100. Do your calculations, you will find x equals 50%. So the correct option, it is B. That was the last question for this video. Thank you for watching. Salam.